Today, basically, we are going to look at the last chapter on KIT 257, which is on corrosion and degradation of materials. So basically, this chapter is slightly long. Maybe I'll spend like 1 week plus for this whole chapter. But hopefully, we are going to finish it as soon as possible so that we can get ready for your test 2 before your exams. Right. So talking about corrosion, you have maybe heard of it during your high school and whatsoever. So things that we are going to address in this chapter is why corrosion and why it is important. What is corrosion and why it is important? How does corrosion occurs? Okay. As we know, corrosion actually occurs basically due to the degradation of a metal with exposure to its environment. Okay, so the environment that we are talking about, okay, is the presence of oxygen and also the presence of water. So this is a well-known fact. Okay, and bear in mind is that for corrosion process, it is a redox process, which means oxidation and reduction occur simultaneously. And what are the forms of corrosion? So you have different types of metal oxides formation. Let's say that we are talking about hydroxides, okay, iron hydroxide. So you have a ferrous hydroxide and ferric hydroxide, and later on there's also different types of rust, oxyhydroxides and oxides, iron oxides. How we can suppress or prevent corrosion? There's a 5 major techniques that we can, I think, look into, and these 5 major techniques for corrosion prevention is the most common techniques, and hopefully you are going to remember this. And finally, how does degradation occurs in ceramics, polymers, and composites? So this is actually the last tiny part of this chapter. It's on the degradation of ceramic, polymers, and composite. But I think more or less for this chapter, we are going to look more on the corrosion process, types of corrosion, methods for corrosion protections, and whatsoever. Okay. So, definition of corrosion. Okay. Corrosion is the degradation or deterioration of material, usually by metals, or chemical or electrochemical reaction with its environment. Okay, so we have known that for corrosion process, in order for metal to have the degradation, it is actually by exposure of this environment. So the environment that we are talking about is the presence of oxygen, water, okay, or we can also have like other impurities like chloride ions, presence of chloride ions, H plus, acid, which means if you have a high acidity, can also triggers to a more corrosive environment, and later on increase the degradation of metals. Okay, and we know that for corrosion process, okay, it is a redox process, so it has oxidation and reduction process occurs simultaneously. For example, if you're talking about the examples of iron, iron, Fe, in H2O solution. So you have for oxidation process the formation of Fe2, Fe2 plus, the formation of Fe2 plus 2 electrons. So this is actually the oxidation process. Oxidation, always remember. So what does it mean by oxidation? Going to test you this time. Alicia Yo, what does it mean by oxidation, if you remember? Or if you can give it in a short definition. What does it mean by oxidation? Alicia? Alicia? Yes.
Gain oxygen.
Gain oxygen. Okay. Apart from that,
Lose electron.
yeah, it loses electron or it produces electron. So this is actually the key for oxidation process. So you know that it produces electron, then this is actually the oxidation process. Meanwhile, for reduction, so reduction, we know that inside this solution, you going to have water and at the same time dissolve oxygen. Okay, right. So O2 plus with H2O, okay, plus with electron first, and it will produce OH minus. So we are going to balance the equation. Okay. So actually you are going to produce 4 electrons. This is going to produce 2, this 4, and this. Okay, this is balanced. Okay. So O2, 4 oxygen, 4 hydrogens, and this one. Okay. So for the reduction process, okay, in the presence of oxygen and water, it's going to produce hydroxide ion. That is why later on, the net of reaction for corrosion is the reaction between Fe2 plus with, for example, 2OH minus to produce FeOH2. Okay, so this is the first form of rust, or known as ferrous hydroxide or green rust. Okay, all right. Deterioration by purely physical causes is not corrosion but described as erosion. So deterioration, penghancuran, okay, of one material, okay, due to physical causes. Physical causes, okay, you have a scratch or whatsoever. So this is actually known to be erosion, not corrosion. Hakisan. Okay. Corrosion process is a spontaneous process. So when we talk about spontaneous process, anyone have an idea what would be um, the level of free energy that it's going to produce? Fatim Fakiha. Fatim Fakiha. Okay, spontaneous. How do you describe spontaneous if you relate this with physical chemistry and thermodynamics? Fatin, ada tak?
Yes, betul.
Okay. So how do you relate? So how did you actually define spontaneous process?
I don't remember betul.
Okay, spontaneous process actually meaning that the process occurs rapidly. Rapid process and spontaneous. When you talk about spontaneous, when you put metals inside the environment, it immediately corrode. So this is actually known to be spontaneous. And the level of the free energy is always negative. Delta G, okay, for spontaneous process is always negative. If you have a negative value for delta G, then you know that this is actually spontaneous because the free energy is very low, and it is easy to overcome. Kita tengok the energy diagram, you know that this is actually EA and this is actually delta G. So if the value is actually very low, negative, so it means that from reactant to product, okay, the process of converting reactant into product will be very much rapid. Okay, so yang ni nak kena letak dalam kepala lah. Okay, you know that spontaneous is always related with delta G is equals to negative value. Anything that produce negative value, you know that the process is spontaneous. And free energy is released in the process. Okay, so how corrosion actually occurs? Another possibility is because metal tends to return to its stable state. I guess I will explain this later on. Okay, and corrosion is extractive metallurgy in reverse. Okay, The driving force for corrosion reaction is actually chemical energy. The energy is stored in the chemical bonds of a substance. And always remember, even during your high school, we have this term, rust. Okay, so rust is always referred as the product of the metal oxide, the corrosion products of iron and iron alloy, stainless steel and whatsoever. So we call the metal oxides of iron is named as rust. We don't call, I think, aluminium, copper, zinc corrosion products as rust, but only for iron that we call it as rust. Okay, so earlier I think I have explained like how corrosion process can easily occur. If you look into this corrosion cycle, how actually you are going to produce pure metals. So I think this one you are going to learn it more detail in chemical processing. Final year, I will teach this one as well. Extractive, one topic on extractive metallurgy. So extractive metallurgy is basically the study of extracting metals. Okay. So the source of metals, in this case, it can comes from ore or metal oxide. So metal oxide normally from metal scrap lah. Okay. Metal ore, kita cakap in Malay we call it as biji besi. Biji besi. Or nanti bahasa kampung ada yang panggil tahi besi. So this is actually metal ore that you obtain. Okay. Obtain from geological activity, mining or whatsoever. Then you obtain metal ore. Okay, metal scrap. Normally this one is more you obtain from recycling. Okay, but this one is completely produced in the most stable state because it's already in oxide form. So always remember that oxide form is the most stable state. Okay. Then you will undergo extractive metallurgy, pyrometallurgy, hydrometallurgy, or whatsoever. Okay. But normally for extraction of metals, you are going to use pyrometallurgy. Okay, pyrometallurgy, it means that the extraction of metal actually reduced by means of heating. Pyro ni temperature lah. You involve temperature. You heat, you melt, you produce smelting process, roasting and whatsoever. Then it will produce a molten metals that after that it can be categorized as a pure metals. And then after that molding and whatsoever, you get the final products. It will be the pure metals. And the pure metal basically is thermodynamically unstable. It is unstable. It tends to react with the surrounding. So that is why people, I think, apply some other things in order to stop the corrosion of metals. If you already produce a pure metal, they apply coating, they apply many things to stop, because you still want the structure of a pure metals, because we don't want it to become oxidized, because when you become oxidized, of course, in terms of the property, it will be brittle because it's more crystal and others. Okay, but I think after certain time with exposure to environment, corrosion process still occurs and it tends to become the most stable or metal oxide. So metal extracted from their ores and are in high energy states thermodynamically, they are not stable. Corrosion is a natural occurring process predicted by thermodynamic laws. It is this tendency of metal to recombine with element present in the environment that leads to the phenomenon known as corrosion. Okay, right. So people talk about corrosions a lot. Okay, so I can talk more on corrosion because my field of expertise is basically on corrosion. Okay, and I'm also basically a professional member of corrosion engineers in US and also a professional member in the Institute of Corrosion UK. So I can talk more on corrosion if you want to know more. Because for corrosion, okay, people have used a lot of metals in industry. You look, I mean, anything is around you. You see that every structure, everything, your car, your fridge, your table or your chair is everything made at least with the presence of metal. So you know that this is actually one of the most important materials in construction and other things. But because of its exposure, okay, to the environment, these materials can easily corrode, and when it corrodes, the properties of this material, metal especially, will start to degrade. Okay, so that is why after certain years, this material need to be replaced. So you can see from there, this is actually a known fact. The cost of corrosion for every country is, I think, estimated around almost 5% of GNP or GDP. GNP is actually gross national product. GDP is actually gross domestic production. Okay, so from the total income of a country, some of it, I think around 5% expenditure will be used for replenish or for the replacement of corroded material. So the direct cost you can see a lot. Mostly is actually to replace, rebuild, um, to apply different types of corrosion protection like coatings, inhibitors, replacement, to use alloys and whatsoever. And indirect costs, okay, it will be due to the loss of production during downtime. So you know what happened in oil and gas especially, or in a chemical processing, okay? So most of the reactors or most of the, I think the equipments will use pipe, okay, to transport one product to another product, okay? So because of we are using pipe and it is sometimes high pressure or high temperature, so you need to use something that is more resistive. So in this case, people are using metals. You cannot use plastic pipes to transport the reacted products or whatsoever. So it will definitely it will break and it will explode. So people are using metal because of its durability, but because of it needs a proper maintenance in several years. If it is corroded, then what happens is that leaking can occur. You imagine that when you have a pipe that is leaking, I mean a gas pipe that is leaking, then you can see that I think the flammable or explosive gas are leaking, and it can actually lead to the explosion, human life and whatsoever. I still remember one time, because my hometown is near to one gas refinery center of Petronas. Okay, what happened is that there's one incident happens which related with the leakage of gas pipeline. Okay, and because of the gas pipeline leakage, I think the parameter of the area has to be evacuated until they have replaced the pipe. So I think it was maybe early 90s or something like that. I mean, it's like very small at that time. Um, then I think we are advised to maybe not to stay near to this area because of the gas leakage and I think methane and whatsoever. So you when you have methane, then you know that it can cause difficulties in breathing and others. Okay. At the same time, it is explosive. Right. So for corrosion protection, this one I think maybe we will see it more detail in the next chapter lah. But it's just a introduction. For corrosion protection, we have 5 actually important techniques that you need to remember. Ingatlah sampai bila-bila. Okay. So the first one is known as material selection. Oops. Material selection. So what does it mean by material selection? It means that in order to produce a material, okay, a metal, for example, then you need to select elements that produce highly resistive to the environment. So in this case, material selection will always related to the production of alloys. Okay. So other than that, okay, we also have proper design. Okay. So proper design is always related to mechanical effect. Okay. Imagine that if you have a very sharp turn in a pipe, 90-degree sharp turn. Okay. Whereas actually you can design something like this to reduce the friction and whatsoever. Okay. Then this can actually reduce the erosion effects, because if you have an erosion inside the pipe, for example, then it is more exposed than oxygen, and water can easily react at that side and produce corrosion. So these two techniques is actually not really, I think, popular. People still use it, but it's not really popular. Okay. The other technique that is mostly popular is, for example, induced current techniques. Okay, which actually related with this electrochemical protection. So induced current techniques, you can have cathodic protection and anodic protection. If you understand a lot on cathodic protection, you can work in oil and gas company, because they are really wanted to use people who have, I think, very good knowledge on cathodic protection. So what does it mean by cathodic protection? So you know that for electrochemical protection or induced current techniques, okay, you have metals that is known to be reactive, and if actually you couple the metals with something that is more reactive than the metal that you are using, okay, then this will give a galvanic effect. Okay, of course. For example, if you have iron, Fe, which normally you use it for your own maintenance, okay, your own facility. You want to protect this from corrosion. So what you are going to do is you couple it with something that is more reactive. For example, like magnesium, or aluminium, or zinc. Okay, then you know that this will be anode and this will be cathode. Anything that will become more reactive, because we know that for anode, this is where oxidation process occur. Okay, and for cathode, this is where reduction process occur. Right. So metal to be protected now become cathode, and the metal that sacrifice itself, or sometimes we refer it as sacrificial anode, is always related with the cathodic protection. Anodic protection is a simple, a special case where it is normally occurs in extreme environment, especially in acidic or alkaline environment. Right. Other than that, okay, corrosion protection can be achieved by controlling the environment. Controlling the environment by introducing inhibitors, corrosion inhibitors, okay, and then by reducing relative humidity, okay, by remove chloride ions or other impurities. So this is where you control the environment. When you control the environment, it can also reduce the corrosion, process. And finally, coatings. Okay, so coatings will be related with inorganic coatings, or organic coating. The examples of organic coatings that we've seen a lot is paint. Okay, all right. So I think with Dr. Chua previously, you have your own group, right, for presentation. Okay, so I know that we don't have much time to present, but I just want to give you a task from the group that you already been allocated previously with Dr. Chua. Okay, so I want every group, okay, to prepare a video, a very short video to explain about the corrosion protection, the types of corrosion protection, and what would be the procedures, what would be the definition, what would be the methods, what would be the aspect that we need to, take care in corrosion protection. So this one you can discuss with your group, okay? Actually, maybe for this one, I give a deadline until I think after Chinese New Year, just before your exam or study week, so that you can able to produce one nice video from your group and then discuss about the corrosion protection method. So I will evaluate which videos that actually give a very detailed explanation on this. Okay, all right. So is it okay? I hope it's okay for you guys. Okay. Right. So moving on, corrosion process, we still look into the definition and I think category for corrosion. So for corrosion process, we know that by definition, it is where the chemical reactions between the metal surface with the environment, okay? But it can occur in a dry condition and also wet condition. So that is why I think in this case for corrosion process, we can categorize it as dry corrosion or wet corrosion. So dry corrosion, it means that the corrosion process occurs with the presence of gas. Remember, for dry corrosion, gas or vapor. Okay. At room temperature, most metal carry a thin outside layer as a result of the reaction of metals with oxygen in atmosphere. Increase the temperature may cause formation of a heavier layer or the layer may detach. Zinc and zinc coatings carry a fairly protective zinc hydroxide or carbonated layer, which increase the thickness very slowly. Aluminium carries a very thin, highly protective outside layer. Corrosion in gaseous environment produce a surface layer of converted metals. For example, atmospheric corrosion of zinc produce a dull, okay, gray zinc oxide seen on the galvanized strip poles. Okay, unoxidized zinc coating, fresh from the hot dip galvanized, is bright and shiny. So what does it mean? It means that for this dry corrosion, for example, you can see a light pole, street light pole, tiang lampu, kan? Jadi lampu lah. Okay. So what happens is that the environment sometimes can be very humid. Okay, it contains more oxygen and whatsoever. So because of that, it attacks. Okay, the strip poles or the galvanized steel and making it become oxidized, and the appearance will be slightly dull. Okay, if you go somewhere in another countries that use a lot of copper, okay, for example in Europe, they use copper. I mean, tower. I mean, they have a copper tower in their churches. They use also copper in their bridge and whatsoever. So you'll see that in some structure, it appears to be slightly green or blue color, or sometimes we call it as patina. Patina is actually copper oxide. I think produced, or even statue. You see that statue that is made from metal and become like blue or slightly green in color. It is actually made from copper. And what happens is that with exposure to the environment in dry condition, it becomes slightly dull, and it become I think less bright or less shiny. So this is actually for dry corrosion. The most common one that you've seen a lot is of course wet corrosion. Okay, yang ni memang basah lah orang cakap. Okay, so wet corrosion take place in relative humidity that exceeds 60%. Okay, so when you have relative humidity exceed then 60%, then it means that it will be mostly wet or watery. Okay, and because of you have water, then it will be considered as the electrolyte of the corrosion process, and therefore the corrosion process is known to be an electrochemical phenomenon because you have water, okay, as the electrolyte. And metals, of course, will be the electrodes. When the two metals are intact with water solution in salts, containing salts, an electric potential is formed between the two different metals or the surface of the same metals with different surface condition. This causes the dissolution of the less noble metal. The more noble metal remains protected, but less noble metal will be corroded. Okay, wet corrosion is most efficient in water-containing salts. So that is why if you see anything near to the seawater, okay, near to the sea, near to the sea or seawater, it will be more corrosive. In the jetty, in port or whatsoever, you see that the structure, the ships and everything become easily corroded because seawater, it contains a lot of minerals inside the water. For example, it has like around 3.5 to 5% of sodium chloride. Okay, then of course this highly conductive, highly corrosive. Chloride also may increase the corrosion of metals. So that is why I think in Malaysia, the treatment for our drinking water is mostly chlorine, chlorination. So if you have chlorine, and those days during my time, I think now people are not using metal pipes. Those days during my time, PBA, Jabatan Bekalan Air tu, okay, they are actually using metal pipes. They just buried the metal pipes, and then you know what happened if there's a leakage, if there's any like maintenance. When you open the tap, you see that the water that coming out is basically a rusted or rusty water lah, color, brownish color, reddish brown color. Okay, the same thing that happens in Kelantan. Okay, so those who are from Kelantan, they will know what happened with their supply. When they open the tap, you see that the color is very red. This is actually not because of bacteria or whatsoever. This is because actually the pipe has not been maintained. So that is why I mean, like these days, people are using PVC pipe to replace. But of course, as I said, plastic pipes after a certain time, it will become brittle, and it can easily leak as well. So corrosion in a wet environment attacks the metal by removing the atoms on the metal surface. The metal atoms at the surface lose electron and become actively charged ion that leave the metal and enter the wet electrolyte. Okay, so the metal ions join with or two oppositely charged ion form another chemical, which is a stable compound. So this is actually very well known. So you have like a metal in water. So what happened is that Fe will become Fe2 plus 2 electrons. So then Fe2 plus will goes inside. Okay, and you know in water you have a H plus, OH minus. Okay, you have a OH minus. So Fe2 plus is a cation and OH minus is an anion. So it easily to react between these two. Okay, and finally it can become a more stable compound as mentioned in the text. Most metal corrosion occurs by electrochemical reaction at the interface between the metal and the electrolyte solution. Okay, so this one I think we have seen, I think slightly during my explanation with you guys just now. And we know that a corrosion process is always a redox process, okay? Which means you have oxidation process and also reduction process. And the oxidation process occurs at the terminal of anode and reduction occurs at the terminal of cathode. All right. So this is actually a very classical half equation. If you have metals, for example, iron in oxygen or water environment, it will produce Fe2 plus and also OH minus or hydroxide. The overall reaction, okay, if you balance this equation, you just remove the two electrons. In the end, you sum it all together, it will become this. And this is actually the first rust that you get, ferrous hydroxide, green rust. Okay. So this is actually a reaction or reduction process that occurs in the neutral pH. Neutral pH normally around 5.5 or 6 to 7. Have you ever imagined if you have acid? Okay. You have a hydrochloric acid, for example, HCl, and you have a metal. In this case, for example, zinc. Oxidation process, we know that zinc will become zinc 2 plus 2 electron. So the reduction process, you have acid plus with water lah. So what will be the reduction process? Anyone have the idea? Anyone knows? Um, just checking. Kamala? Kamala, are you there?
Yes, doctor.
Okay, Kamala. Right. So what will be your prediction? If you have a metal, zinc, for example, you put in a dilute acid solution, you have the oxidation process of zinc to become zinc 2 plus. So what about the reduction process? Do you think that is going to be the same as this one or it will be different?
Mm, I think different.
Okay, so if you think different, what will be the reaction? You learned this in high school.
Mm,
Can't remember.
no.
You can't remember. Okay, never mind. Let me ask another person. Li Jing. Li Jing, are you there?
Yes, doctor.
Okay, Li Jing. So I think just now Kamala have told that the reduction process will be different as compared in neutral condition. So what do you think? Do you have any idea what will be the reduction process of zinc metals in dilute acid solution?
Maybe produce zinc chloride,
Zinc chloride. Zinc chloride actually the product. Okay.
hydrogen gas.
Okay. Very good. So I take that one, huh? Zinc chloride and hydrogen gas. You see, if you react zinc with acid, you have zinc chloride as the product. Okay, this is actually maybe we call it as the stable product that forms on the surface, and this is actually the side product. Okay, so this is actually your reduction process because you know that this is where the oxidation process occur. Zinc to zinc 2 plus that reacts with Cl minus to produce zinc chloride, and the reduction process. Okay, so you have HCl or H plus over here that when it reacts or it becomes H2. So the reduction process of a metal deep in dilute acid solution, because we know in acidic solution, okay, you have H plus, OH minus, okay, and maybe Cl minus. But in this case, which ions that you think will be more dominant? Of course, H plus, because you have it from water, you have it also from the hydrochloric acid. So this will be more dominant. You have more of H plus as compared to OH minus. This you have less, slightly less in acidic. Okay, so the reduction process will be the formation of hydrogen gas. So you have 2H plus 2 electron that produce H2. So this the reduction process anywhere if actually it deals with metal in acid pH, in acidic solution. Okay, so always remember that. So I think later on in your third level, industrial practical, you have one experiment with me on corrosion. So part of the things is that you have to predict what will be the reduction or oxidation process in different pH condition. So you have to know in neutral what will be the reduction process, in alkaline what will be the reduction process, in acidic what will be the reduction process. Okay, there are obviously different anodic and cathodic reaction for different alloys exposed to the various environment. So this is actually to explain. You have a different reaction. Tak adalah kita cakap Fe to Fe2 plus even though we are talking about copper. So you have like copper become copper 2 plus for copper. Zinc to zinc 2 plus. Aluminium to aluminium 3 plus. And if actually the environment is acidic, for example, then you have 2H plus 2 electron produce H2. Okay. In the neutral, then it will produce OH minus or hydroxide ions. I hope you are guys clear on this. All right. So this is just a repetition of what we have explained just now. Okay. So in this case, oxidation will occur in anode. Reduction will occur in cathode. Okay. The environment will be always related or referred as the electrolyte. The connection between the anode and cathodes, okay, will produce this electrochemical effect. It will actually assume to be electrochemical corrosion cell. So this, I think, the most famous picture that you've seen even during your high school. You've learned this in, I think, SPM Form 4, about electrochemistry, about corrosion specifically. Okay, and even in A-level or matriculation STPM, you have learned this. So I think you know that the oxidation process occurs at the anodic region, reduction process occurs at the cathodic region. If you have a droplets of this, okay, you can see which region is actually anode and which region is actually cathode. Okay. So corrosion chemistry of iron. So now we are talking about specifically on iron. Okay. We know that iron can produce different types of rust. Okay, depending on the amount of oxygen, depending on the amount of water or the concentrations of the impurities in the electrolyte. So it will produce different types of rust phase. But the process actually occurs with the start of producing Fe2+. Okay, so this is where the corrosion of iron occurs. You have Fe become Fe2+. The electrons are quickly consumed by hydrogen ions to form water and dissolve oxygen at the edge of the droplet to produce water. Okay, so then you have a reduction process, okay, that occurs, right? So more acidic water increase the corrosion. If the pH is very low, the hydrogen ion will consume the electron anyways, making the hydrogen gas instead of water. So this is actually what I explained to you just now. Or in acidic condition, okay, you have more H+, then this actually will consume your electrons produced for the first reaction, okay, to produce hydrogen gas as the reduction process. Okay. Right. So Fe2 plus tends to react with the opposite ions. In this case, the reduction process produce hydroxide ions, OH minus. Then it will be reacted together to form ferrous. So you know that iron 2, this is referred as ferrous. So ferrous hydroxide. Okay. And ferrous hydroxide is normally temporary. It's not really stable. It tends to further oxidize to form Fe3. So Fe3 we call it as what? Siapa tahu? Fe3 we call it as No Atirah? No Atirah Laili. Atirah.
Ya, Doktor.
Atirah, Fe3 kita panggil apa? Tadi Fe2 kita panggil dia ferrous. Fe3 Pisvirus.
Tak sure lah, Doktor.
Tak sure, Masya Allah. Okey.
Ferric.
Nasib baik. Okey. Ferric. Ingat, Fe3 we call it as ferric hydroxide. Okay. So notice the difference. Okay. The difference is this. See over here is 2 and here is 3. Because you know, okay, Fe3 plus and this is actually OH minus. So you have one ions on OH, and then Fe you have 3 plus. So will be transferred to over here. 1 is here. The loose porous rust or ferric hydroxide. This one we call it reddish brown. Reddish brown in color. Reddish brown. Okay. Can slowly transform into a crystalline form written as hydrated. Sebab dia ada water. Hydrated ferric oxide. Ferric oxide, or the familiar name as red brown stuff or rust. Since this process involves hydrogen ions or hydroxide ions, they will be affected by the changes in pH. With limited oxygen, magnetite can be formed. Magnetite is actually Fe3O4. This is actually another forms of metal oxide or iron oxide. Okay, so I guess last slide for today. This is actually what I'm talking to you just now. Okay, we have a different rust phase that can be formed. Okay, after the first two reactions. So oxidation and reduction produce the green rust. Okay, ferrous hydroxide, and then it forms ferric hydroxide. Okay, more oxidation because, as I said, ferrous hydroxide is less stable. Okay, it tends to form ferric hydroxide, and further oxidation and hydrolysis, it will produce different types of rust phase because depend on the amount of oxygen, water, pH, and whatsoever. So you have a different mixture. Okay, so you can have FeOH. This one we call it as oxyhydroxide. Okay, and you have alpha, beta, delta, and gamma. So this actually depends on different crystallinity, crystal structure. Okay, so you can have alpha as geotite, beta as arcaganite, delta as ferroxide, gamma as lepidocrosite. And others will be mentioned as like magnetite, Fe3O4, okay? And then you have Fe3 ferric oxides and hydrated ferric oxide. And finally, the formation of corrosion products of iron. If you have the pure metals, when it start to oxidize, it start to form the first layer of ferrous hydroxide. And then after that, further oxidation forms another layer, okay, of ferric hydroxides and oxyhydroxides. And finally, if you have more rust phase, then it forms another layer, another layer. So that is why I think for corrosion product, it's always like layer by layer formation. Okay, all right. So for this one, I guess maybe we are going to continue tomorrow. Okay, so for tomorrow, basically, I have something in the afternoon. So I'm just checking whether it's okay to have class slightly early, around 9 to 10. If you guys are free, you can join. If you're not free, then it is pre-recorded. Then you can watch it in YouTube. Okay, so tomorrow, just for tomorrow, I will do it around 9 to 10, just only for tomorrow. Okay, so I will stay back if you have any further question. If you don't, then I would like to thank everyone for listening to today's, I think, lecture. So thank you very much. And if you have other questions, so please ask me after the class. So thank you, and Assalamualaikum warahmatullahi wabarakatuh. See you tomorrow.